Welcome to Design Hub, the official podcast of the Institution of Engineering Designers. I'm your host, Molly, and today we're joined by an extraordinary guest who has had a massive impact on the world of technology and education. Today we're speaking with Pete Lomas, co-founder of the Raspberry Pi Foundation. Pete's work has revolutionized computer science education, and his inventive contributions have inspired countless generations, educators, engineers, and students worldwide. So, Pete, thanks for coming on.
Hi, hello.
So to start, could you tell us a little bit about your background and how you kind of got into this field?
Yeah, I suppose when I was young, we didn't have a great surfeit of toys, so I started by modifying bits of cardboard from the corner shop and using marbles to make these things called marble runs.
Oh,
I
I
don't know
remember
whether you've
those.
seen those. Um, then it really was, it was a case of, I moved on then. My father was an electrician. So I moved on to electrical things, and it was really when I was about I was about 12. I was allowed to go into Manchester on the bus. I mean, something you probably wouldn't think of now for 12-year-olds. And I came back with a quarter of a telephone exchange in tow. I literally took it apart bit by bit. So it was just relays, uniselectors, diodes, all that sort of stuff. I took it apart bit by bit and made myself a noughts and crosses machine that would play noughts and crosses with you. So I suppose I've always been a maker. And that probably coloured my school education because nobody really explained why I was learning this. So I escaped school at 16 and went to a technical college. Now, this is quite a few years ago. So this technical college had a PDPA computer. It's one of the first few mini computers that were in the UK. And I popped my head round on the first day and looked at this bright, shiny machine with flickering lights and said, "Oh, that's interesting. What is it?" Now, the guy who looked after it, called Graham, said, "Oh, well, that's our computing facility for the degree students." Ah, I'm on an ONC. I said, "So can I use it?" He said, "No, it's only for the degree students." And so I turned on my heels and he then said, "Well, I suppose you could always come back at lunchtime. They don't use it then." And I literally went back pretty much every lunchtime for my 2-year career at Bolton.
Wow.
And I was just fascinated by the computer. And I think what really got me started was the fact that he'd sort of given me the encouragement to have a go. He gave me the inevitable first program in BASIC, which is to print Hello World and then keep printing Hello World. And he didn't tell me for quite a large amount of paper how to stop it using the Control C. So what he actually did for me was sort of give me that, like I say, encouragement to do it, but also then gave me that sort of element of control. And I went back lots of times and asked him questions and all of these things. Graham didn't have to do this for me. I wanted to learn as much as I could about um, computers. So I decided I wanted to go to Manchester University. I then had no matriculation because I needed English language, I needed English lit. So I did those at night school. And I went to Manchester University. And then I spent, 7, 8 years there, and then moved into the dark side or industry as they saw it. So that's sort of a potted history. I worked for a couple of years for a computer company just to get an understanding of how business worked. Then I set up on my own, and then from that I started running companies, designing and building electronics. Because fundamentally, I like making things. At
Yeah.
heart, I'm a maker. I suppose a maker, aka an engineer.
I like that. And with your experience in industry, how did you sort of get involved with the idea of Raspberry Pi and the creation of the foundation?
Well, I think this is really, it was really interesting. So as I said, Graham didn't need to do what he did for me, but he actually changed the course of my life by giving me that opportunity. And it just sort of bugged me for years. How can I do what Graham did for other people? And I did it in an ad hoc way, helping, the odd student here and there. But then I was down at Imperial College at a meeting, and there was this guy sat next to me. We just got chatting, and it turned out he was a professor of computer science at Cambridge. And he said, well, we sort of have this idea now that all the computers and everything that everybody's got are locked down. It's difficult to modify them. It's difficult to actually do projects on them. And so we've got this half an idea of creating a little computer that we're going to give to the students before they actually come to Cambridge and say, go and do something useful with this, because they didn't have any practical experience in programming as such, because all the coursework was just make this happen, make that happen. And the little computers that we had when I was sort of the kid, the Spectrums, the Acorn, the BBC Micro even, and if you could afford it, something even better, it's all sort of died out because the advent of the PC killed them all off. And now what the kids have is Xboxes or iPads, and they're really difficult to get into, and they're locked down for very obvious commercial reasons.
Yeah.
Anyway, so I went to a meeting in October 2008. It seems forever ago. 3 academics, an entrepreneur, a silicon designer, a games developer, and 1 electronics designer maker, aka me. And we sat in that room and said, we're going to do this. It's got to be a good idea. We didn't, and we realized that if we were going to do it, we needed to be very clear that this was mission over money. And so we decided we're going to create a charity to do this. And of course, the benefit of that is with that charitable mission statement, we got massive support for our activities from individuals, from education, and from companies.
Yeah, a lot. I feel like if you believe really strongly in a mission, you'll find other people quite easily who also believe strongly in that mission. I don't know if that
Well,
might
that's true, especially if it's a good mission, to actually get kids
definitely.
involved in engineering
And
through computer science and electronics.
so when you were sat down in your working group, that initial thought process, and you were going through everything that you needed to sort of accomplish and achieve, were there any challenges that kind of came up and you thought, oh, this could be quite a hindrance, or this might slow down progress? And is there a way that you all sat down and thought this is how we kind of overcome it?
I think, yeah, there was there was always a number of challenges. Our first challenge was trying to figure out exactly what we needed to do.
Mm.
One thing that was very clear is it needed to be cheap enough to break. That was what one of Evan's famous phrases, it has to be cheap enough to break. And he's right. Because if you do not have it cheap enough, then they won't risk take with it. If you don't risk take, you don't develop. You
I like
can't
that.
imagine solving. Sorry.
Oh no, I really like that. I like the fact that if you don't break something, you don't know how it works, and if you're afraid to break it, then you'll never know how it works.
Well, I don't think breaking it is mandatory, but not worrying about breaking it is the
Mm.
thing that's mandatory. Because otherwise, you can't imagine somebody taking, the back off their iMac or, their netbook Air and starting to solder wires to it to make an LED light up. They're just not going to do it.
Mm. Yeah.
So I think the biggest challenge we had was, so it has to be cheap. And then I ask everybody, what do we want on this platform? And of course, the list is enormous because everybody, from that collection of people, everybody had different opinions. So paring down that specification to the essentials was a real challenge. But we got there. And then, of course, the other massive challenge was to make it for $35, because we created a website and we thought, well, what's the price point we need? Well, the $35 went on the website before we'd actually got a final design. It was a little bit, but we sort of knew we could push it, we'd get there. But the thing that helped is being a charitable mission. I could go along to suppliers and say, look, guys, we're trying to do this. Now, I know full well that if you were selling this chip to somebody like Sony or IBM, it would be about 35 cents. You're going to try and sell this to me at $1.35. We're a charity. Can you give us the 35 cents price? Some said yes, some said no. So we sort of had a little bit of picking and choosing. Some of it wasn't our choice, we couldn't get it. But eventually we got a large enough cohort of component suppliers, so we actually had a good chance of building for the price tag.
Nice.
Here's the other challenge with the PCB. Trying to design a PCB with a high-end processor on it that used very basic technology was quite difficult. But one thing I think that came out of that is the power of networks, because I networked with my PCB suppliers. I said, look, this is what I'm trying to do, and this is the problem I've got. And I just sort of idly said, well, in high density interconnect PCBs, which are really expensive, we put these things called blind vias in with a laser. I said, how much does that actually cost? And they go, oh, no, that's not the expensive part of the process. That's really cheap. The expensive bit is where you have to do a multi-lamination. Now, we're not going there on this call, otherwise we'll be here for weeks, okay? But in essence, that conversation gave us a way into a solution that we used on the original Raspberry Pi, and that got us to the $35. Sadly, we had to make the first ones in China because they were the only people that would give us the assembly cost. But of course, you'll know in the story that we very quickly moved to Sony and Pencoed in Wales, and they've made literally millions, well, actually millions of Raspberry Pis in their factory.
Wow. Would you say that networking was an essential part to getting Raspberry Pi off the ground? Would you say it definitely helped?
Oh, I think networking was crucial in two forms. Networking with people who were, if you like, aligned with the mission, and also networking to actually attract people to the mission to probably help in latter stages and get interested in it. And one of the sort of funny moments was that Liz Upton, Evan Upton's wife, we managed to cajole her at a meeting in a Chinese restaurant in Manchester. We managed to cajole her to come and do the website and the sort of media management for Raspberry Pi. And because she was publishing the project as it went along, we garnered more interest actually from across the globe. And then I think it was the Christmas we got them working. We sort of asked everybody, oh, well, if we made these, I mean, we were going to make about 3,000 initially. If we make these, are you interested? And we got 200,000 people came back saying we would like potentially to buy one.
That's insane.
Well, it was back then. I mean, it was. I think in large part it was down to Dave Braben, who knew Rory Kethlan-Jones, who was the BBC's science and technical correspondent, and he just did a little YouTube video of a sort of very rough prototype of Raspberry Pi, and that had tens of thousands of hits in the first week, which back then, right, you're going to wind this back, was quite significant. And that, I think, helped to garner the interest. But also what it gave us is literally thousands of people who were aligned with the mission, who wanted to help in some way or other. Because I'm absolutely convinced that Raspberry Pi would not have existed without those people who were prepared to just contribute their time, either in a resource to how to do something, or in a sort of, I'll go and run a club and try and teach people about Raspberry Pi. All of those people, immensely valuable. And I'm immensely humbled they all wanted to get involved
Oh,
in this project.
I was going to say, did you ever imagine the global impact that Raspberry Pi could have could have made?
No, we really didn't have a clue. And right back, I mean, it started to die. I mean, obviously the big thing was when they actually, said, "Oh, 200,000 people are interested in it." But I think, there was definitely a split. There were people who were interested in buying the piece of technology to have a go with it, and there were others that could have wanted to buy the technology to have a go with it and then use it, if you like, for the mission. But no, we didn't have any idea how it would grow. It just wasn't. Well, it certainly wasn't on my radar. I think Jack Lang, who's sadly passed now, had an inkling that we could do something really big with this.
Mm.
Um, and so I think that was important. And I think the other thing that happened is that we recruited Philip Colligan to Raspberry Pi, and he's done an immense amount in actually taking us forward.
And the Raspberry Pi can be used for lots of things. Personally, I do want to give one a go, and learn more about that kind of that world. But I'm sure you've seen the Raspberry Pi used in lots of different creative ways. Is there any one project, or maybe like another project that you've seen it being used in, and you've thought, I wouldn't have thought to use it like that?
Oh, right. I mean, we could probably spend the rest of this podcast talking about the brilliant projects that I've seen over the time, and it would be really hard, to choose one. I mean, I think what I'm in awe of is the creativity and inventiveness of the young kids. I mean, we designed Raspberry Pi without a case deliberately to expose the technology. A few months after Raspberry Pi existed, Biz, who was a Girl Scout at Breeden, which is not too far actually from where I live, came up with a Lego case that actually fitted a Raspberry Pi perfectly.
Oh wow.
And that's it. And then what I really loved was the guy who made a magic mirror, which basically has a screen. It has a screen behind it, so it actually displayed. You can display things whilst shaving or whatever you're doing.
Oh,
And it showed the train times, and it also showed the weather. And somebody said, "Well, why does it show the weather? Because you can look outside." I said, "No, this showed the weather in London, and he was commuting from Brighton to London. It showed him his train times for his commute. So if the train was cancelled, he didn't have to rush so much. And it showed him the weather, so he knew whether to carry the coat. It would also show him any underground problems it was brilliant."
wow. You mentioned that a Girl Scout used them. So, but this is a product for all age ranges, yeah? Um, and
Oh, absolutely.
um, when it comes to getting children or young people into technology, um, is there something that you think is really important to inspire the next generation in STEM careers?
I think for me, the thing is, or the special thing is that the kids have an idea, a project that they want to do. It's not anybody else's. It's not been written down by somebody else. It's their project, and they design it. They'll maybe have to make a bit of hardware. They'll maybe have to do a bit of software. They'll then go through the pain, anguish, and often tears of actually trying to get it working, and they're going to need some help through that. I say it's a bit like a steep, climbing a steep hill. At some point, it gets that steep. You do need somebody to give you a bit of help. But once you're on the other side, it's fine. But when you get to that pinnacle when it actually works, then, the kids are incredible. They're all high-fiving, dancing around the table, and the sort of adrenaline and endorphins are going like crazy. And they suddenly get what actually engineering is about. It's about making things and achieving a solution.
Mm.
And they think, I want to do that again. And that sort of gives them the impetus to think about engineering as a career.
Wow. And for any educators or schools that want to get children involved in the STEM kind of world, what would you say to them?
I think this is really difficult. I mean, it's a super challenge now. I mean, we have, giving the kids access to creativity, I think is the key. Like I've just said, if you can actually give them that sort of moment of achievement,
Mm.
then it's a proud moment for them internally. It builds their self-confidence, but it's so difficult to do in an educational environment. I think the key thing for engineering is now critical thinking. I mean, AI will do a lot of the drudge work for you, but it won't do the critical thinking to invent things. But I also think it's good to have a grounding across a lot of other disciplines, so you have a rounded view of what we can do.
Mm.
It was quite interesting. So my son thought he wanted to do natural sciences, so I thought, well, yeah, so you ought to do GCSE Latin because actually, because Latin's used in a lot of that area. But then he realized that actually Latin is a very structured language. It's far simpler than English when you get into it because everything is actually well structured. And
Mm.
it's probably the engineer's language if we wanted one. And bizarrely, he's now gone off and done computer science after his degree in natural sciences because he likes the logic of it. But I
Wow.
think DT in school is the thing.
I love DT. I did it at GCSE.
Yeah, we need to give, it needs to be funded and elevated to a similar importance as maths and physics, and chemistry. And it
Mm.
needs to have a high practical element because that's what gets kids, involved. But it's a massive, and it's a massive, huge challenge. But it's one I think ultimately we're going to rise to because some of like I say, a lot of the other stuff may be done by technology, and it's that critical thinking, that inventiveness, and that creativity is really the thing that will take things forward.
Well, you mentioned technology and the new stuff that's coming in, and obviously technology is evolving now quite quickly. And you mentioned the AI. Are there any technological trends that you're excited for the future?
I think that the technological trend that I've always been excited about is that going back to that original PDPA, and it had 8 kilobytes or kilowords of memory. And now we're talking gigabytes of memory, we're talking processor speeds in gigahertz. And so I started back then with the view of, well, with this little PDPA, I can do this. If I can write the program, it will do my bidding.
Mm.
I think the thing that really excites me is that it's not quite exponential, but I think as Moore's law said, it's doubling every 2 years the number of transistors. So where computers, engineering, electronics is going to go and what it can achieve in the future is going to be tremendously exciting. I don't think any one technology is going to be the key. It's going to be the integration of bits of technology from all areas in materials, in electronics, because it tends to pervade a lot of systems now.
Mm.
Um, and then aerodynamics maybe, and even civil engineering will change as a result of being integrating technology across the piece. So yeah, I'm always excited. I think AI will settle down into something practical and really useful. It's a little bit in what I call the hype space at the moment, you know.
Yeah.
But I think it will offer stable solutions that don't suffer from garbage in, garbage out problems, and it will be a massive benefit to society. Because one of the things I do find is that Raspberry Pi run this thing called Coolest Projects, and kids come together and show off the things that they've invented. And I think the thing that cheered me more than anything about that, apart from the sheer brilliance of what they did, is the number of projects that actually had a societal benefit. The kids were thinking about how they could make the world a better place. And that's what, as engineers, we should be looking to do. Just because you can doesn't mean that you should. And you really have to think in the round about, the ethical aspects of what you might be creating.
I like that. I like the fact that you think that people should think about the kind of the things they're putting out there. I think that's really good. Is there anything else you'd like to share with our listeners about your journey or your work? And where can they find more information about you and the Raspberry Pi?
Certainly, you can find me on LinkedIn, that inevitable source of very small amount of information. But for the Raspberry Pi Foundation, if you're interested, just Google Raspberry Pi Foundation. Now, the interesting thing now is we're split. The hardware side that we developed those years ago is now a PLC on the stock exchange, and the foundation is a completely separate entity with a mission that we've always had to actually educate and enable people to really have their full potential by giving them the tools to do what they need to do.
Amazing. Well, thank you so much for joining us. It's been amazing to speak to you today. And for all of our listeners out there, don't forget to follow us on Instagram, Facebook, and LinkedIn. And until next time, goodbye.